Okay, ladies and gentlemen, let's talk about triangle theorems, part two, particularly congruent triangles. Now, we're going to go with the duh theorem of the day. The duh theorem of the day says that if two figures are congruent, then all of their parts are congruent. Duh. Because if two figures are the same, it would make sense that they're going to be made out of the same parts. So let's talk about that. We have triangle ABC is congruent to triangle DEF. Now you're saying, Mr. Moore, those do not look like they're the same size. This one looks like it's maybe obtuse, and this one looks maybe acute. Here's the thing about congruent figures. They're congruent if I say they're congruent. More importantly, they're only congruent if you are told specifically that they are indeed congruent. You cannot look at this and say those are the same or are different unless you have that they are indeed congruent and you have been told so. So, in this particular case, the next thing we need to talk about is corresponding parts. If two triangles are congruent, corresponding parts of congruent triangles are congruent. So the whole point is, if I have two triangles that are indeed congruent, ABC is congruent to DEF, that's what it says, then I can say that corresponding parts of congruent triangles are congruent, also known as CPCTC. Corresponding parts of congruent triangles are congruent. So if I wanted to start here with A, B, and C, I want to make a list of all the corresponding parts. Angle A is congruent to, well, I don't know. In this case, I have A, B, C, and I have D, E, F. So A has to go with D. Because if they are listed in this order, then that means this angle here and this angle here are exactly the same size. That means that angle B is also congruent to angle, well, B is second, E is second, E, and so on and so forth. Angle C is congruent to angle F. Now, that's just the angles, but remember, every triangle has three angles and it also has three sides. So in this case, I would say side AB, oh, wait a minute, I have failed to mark my triangle. B went with E, and C went with F. So there we go. Now, I have side AB would have to be therefore congruent. Well, AB goes with DE. And so I now need to label that with a tick mark. Then I can say EF is congruent to BC. You'll notice I started over here this time, which is no big deal because remember, if this is the same as this, this is the same as this, it's actually biconditional. There is one more set of sides, and you guys need to tell me what those are. All right, now let's start talking about HIJ and KLM. So if I say that triangle HIJ, that's the given, HIJ, is congruent to KLM, then we need to be able to talk about congruent parts. Now, the challenge is this is not oriented the same as the other. So H goes with K, so that goes together. I goes with L, but you'll notice you can't just look at things and determine which ones are the same. You actually have to read it through. And finally, J and M. Now, if that's the case, I need you to answer the following. If I have HJ, what is HJ congruent to? Well, H and J, that's from the single to the triple. So what side is between the single and the triple over here? KM. All right, if we have, I want to know what goes with LM. LM, well, that's double to triple, so that's going to be IJ. So you can find the corresponding parts of congruent triangles are congruent. This is going to be a massively important theorem, and it's all based off of this guy right here.